Good morning, this is your stat sensei, Mr. Sensei, and this is pre-quiz problems 3 through 4. So during the Pepsi challenge of the 1970s, Pepsi asked volunteers to have a drink of Coke and a drink of Pepsi. Participants did not know which beverage they were drinking. Participants were then asked which drink they preferred to drink. Your task is to recreate the Pepsi challenge. You must create a diagram, so we have to create a diagram for a matched paired design. All right, matched paired means tested twice, 2 times. So each participant is going to test twice. They're going to test Coke and they're going to test Pepsi. Be certain to identify the number of people in each group. And we have 84 participants, so our sample size in this case is 84. So 84 people are going to have both different both try both Pepsi and Coke. So what we're going to do is we have random assignment of 84. All right. 42 will try Pepsi first and then followed by Coke. And the other 42 will try Coke first, followed by Pepsi. And the reason we do that, the reason we swap the order is if you're eating a bunch of donuts because you're a real pig, your first donut is usually your best donut. If you're eating 6 donuts, by the time you get to number 6, they don't taste so great. All right. You're just eating to be eating. All right. But the first bite of that first one is usually the best tasting one. So that's why we swap the order so that each one has an equal chance. So 42 they'll be randomly assigned to 2 groups. 42 will try Pepsi, followed by Coke. The other 42 will try Coke, followed by Pepsi. And at the end, we're going to say, hey, which one do we prefer? So our response variable is which one tastes better. All right, so that's our diagram. Describe how to conduct the experiment. I place 84 participants in a bin and mix. The first 42 names would drink Pepsi first and then Coke second. The remaining 42 names would be assigned to the group that will taste Coke first, then Pepsi second. After tasting each drink, participants will fill out a questionnaire to determine which drink they preferred. All right, and we could label this one, okay, this is A, this is B. Did this group prefer A or B? And then one, did they prefer A or B? That way you never know which one they're getting. All right. So, part C, explain how to volunteer the testing the drinks. We can label the volunteer by pouring Pepsi and Coke into cups that are already pre-labeled A and B. The taster will drink each cup and thus will not know which product was already assigned to each cup, nor will they know the order that they tasted each drink. Can this be done as a double blind? And the answer is yeah, it could. As a data collector, I just know that they had cup A. I don't know what's in cup A. It could be Coke, it could be Pepsi. And we already said that the person drinking wouldn't know. Yes, the experiment can be double blind because the distributor would hand out the cups already pre-filled and labeled to the data collector. The data collector would not know which product was given to the taster, and the taster would not know either. All right. So in this case, this could be done double blind because neither the data collector nor the taster would know. All right. All right, number 4, a randomized block design with 720 volunteers. Okay, this is going to be important. We have 720 volunteers. Was created to examine the effect of different exercise types on cognitive performance. Okay, so once again, we're talking about brain function. Are you smart? And considers the impacts of age broken into 2 groups and income levels broken down by quartiles. All right, so here we go. First off, we're going to block by age. And they only had 2 levels, young adults and old adults. So if we have 720 and it divided out nice and evenly, which it doesn't necessarily have to for blocking, but we have 360 in each group. Then we block again. By the way, this is another blocking variable. It's income level. All right. Those that make less than 30,000, those that make between 30 and 50, 55 to 95, and those that make above 95. So we have that 360, and you see that we quartiles 1, 2, 3, 4, 360 divided by 4, and we ended up with 90. All right. So we ended up with 90 in each group. And then um, we had exercise. And on exercise, we broke it into no exercise, strength, and cardio. So we took that 360, divided by 4, got to 90, and now we're going to divide that by 3 for the 3 groups, and we ended up with 30 in each group. All right. Could this be performed as a double-blind or single-blind experiment? Justify your response. Gosh, I'm looking at this and I'm going, couldn't be double-blind because, again, if you're making me exercise, I'm going to know it. All right. Now, I can sit on a couch and be quite comfortable, but if you're making me exercise, I'm going to know that. So, no, this could not be double blind. The person being tested would know whether there's exercising. Could this be done by single blind? And the answer is yes, it could be done by single blind because the data collector wouldn't have to know which treatment I got. The data collector wouldn't know whether I was sitting on a couch eating chocolates and potato chips or whether I was doing strength training or cardio. The data collector wouldn't know, so they would be blinded, but the person doing the exercise would know if they were exercising or not and what type of exercise they were doing. All right, comparison of results. What are we comparing? Well, we're comparing, and they told us up here, it's cognitive performance, and that's what we labeled it right at the end. So our response variable, by the way, if you notice, these two things have been the same every time. The response variable and what we're comparing, they're the same. If you do something different, you're silly. They're always going to be the same. If you got one, you have the other. All right, list the explanatory variables and the number of levels for each. Well, if I'm looking at the groups, I divide once. Well, that group was divided based on age, and it had 2 levels. Then I divided again, and this time it was based on income. And I have 1, 2, 3, 4 levels. And I know you want to include these and go 5, 6, 7, 8, but notice these 4 are the same as those 4, so we only have 4 different levels. So we don't count the repeats. And then over here, we have our next group. That's our next division, our next set of arrows, and our next division was exercise. I can't apparently spell exercise today, so I'll try again. Exercise. And we have 1, 2, 3, because then it repeats 1, 2, 3. So we have 3 levels. So list the explanatory variables. Well, we blocked on age, 2 levels. We blocked on income, 4 levels. Those were the quartiles, and we had the 3 levels. List each treatment. All right, this gets very long and tedious. So here's what I would do. I would go Y1 in, or Y10, or I go Y1 in, Y1S for strength, Y1C for cardio, Y2, etc. So here we go. Young 1, 0, young 1 strength, young 1 cardio, young 2, 0, young 2 strength, young 2 cardio. And we keep doing that. And look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have 24 levels. And if I count this up, it better match. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have 24 levels. I'm going to put this up so you can see it all. And once again, you can abbreviate, and I'll show you what that's going to look like. I could go young 1, no, young 1 strength, young, 1, cardio. Young, 2, no. Young, 2, strength. Young, 2, cardio. All right. And just to make it short, I'm only and do that, then I'm gonna do an old one. Old one, no exercise. Old one, strength. Old one, cardio. Old two, no. Old two, strength. Old two, cardio. So it is fine to abbreviate to speed that up. So we have an advantage when we're typing this that it doesn't take too long, but if you have to write it all out, it helps to abbreviate. All right, I sure hope this helps. I sure look forward to seeing you on the next one. Thank you.